All right, so here we're going to be graphing linear inequalities. So again, a linear inequality is just like a linear equation, except we have a inequality symbol instead of an equal sign there. Solutions are any ordered pair that makes the inequality true. In this video, we're only going to be doing standard form when the coefficient for the y variable is positive. There's a little trick when it's negative. We're not going to cover that in this video here. All right, let's jump into it. First off, is the coordinate point, the ordered pair 1, 2, a solution to the linear inequality negative 3x plus 4 greater than 5? So a way we can do this is substitute the 1 in for the x and the 2 in for y and see if it makes a true statement. So here we go. 1 in for x, 2 in for y. Now we do order of operations. We got multiply first, negative 3 times 1 and 4 times 2. That's going to be a negative 3 and an 8. We're still doing order of operations, and we're checking to see if this makes a true statement here. Negative 3 plus 8 makes positive 5. 5 is not greater than 5. If this was a greater than or equal to, then it would be. But in this case here, 5 greater than 5 is a false statement, so the coordinate point, the ordered pair 1, 2, is not a solution to this linear inequality here. Now let's say we wanted to look at all of the ordered pairs that makes this inequality true. A way of doing that is by graphing it. So we're going to graph the boundary line first, and that's where, at least in our brains, we're switching the inequality with an equal sign and then drawing this line here. This is in standard form, so a fast way of graphing in standard form is by finding the intercepts. So here we go. So the x-intercept, we're going to divide by negative 8. So we're going to go 24 divided by negative 8, and that's going to be a negative 3. Now for the y-intercept, we're going to divide by 6. So 24 divided by 6 makes 4. So since it's or equal to, we're going to use a solid line for our boundary line. There it is there. Now that we have our boundary line, now we look to shade. So this is a greater than, so we're going to be shading above the line here. So now we can look, any of the ordered pairs in this area here or on the line is going to be a solution. So here we go. Some quick questions here. Is negative 2, 3 a solution? Well, let's look. Negative 2, 3 is going to be right there. It's in the shaded area. So yes, that is going to be a solution. What about the ordered pair 3, 1? 3 for the x, 1 for the y. Well, that's going to be here. It's not in the shaded area, so no, not going to be a solution. Last one, 0, 4. There's 0, 4 right here. It's on the line. Since it is or equal to, any ordered pair on the line is, yes, a solution. All right, for this example here, go ahead and pause the video and give it a whirl, and then come back when you're done and see if you got it right. So we're going to start out by graphing that boundary line. So that's where we switch the, in our brains, switch the inequality with an equal sign, and then we're going to draw that line. So for the x-intercept, that's going to be 10 divided by 2. That makes 5. So there's our x-intercept. And then for the y-intercept, divide by 5. 10 divided by 5 makes 2. So there's our y-intercept. Now this is strictly greater than, so we're going to use a dashed line for greater than. It doesn't have the or equal to, so we have a dashed line. Now that we have our border line, our boundary line, now we're going to shade. This one is also greater than, so we're going to be shading above the line here. So there's all of our solutions there. If it's on the line, not a solution for this case here, and then anything down here also not a solution. So again, when graphing these linear inequalities, we do want to draw the boundary line first, and then shade the solution area. For greater than, we shade above, and for less than, we're going to shade below the line there. Now, this only works when the coefficient for the y variable is positive. If it's negative, you're going to switch the direction that you shade.